Hi ladies and gentlemen, I am going to do a quick video on your PN42 notes. So up here I'm going to write PN42 for your record, and it's going to be about polar coordinates. But before we get into polar coordinates, I want to just kind of take a step back and make sure that you're feeling good about our good old-fashioned Cartesian coordinate system, or a lot of teachers or people will call it the rectangular coordinate system. But it's the one where if we plot this point right here, this point A, we go over 2 horizontally and then up 4 vertically, and this would be our point A. And of course our B, we're going to go over -3 right here, and I'm going to actually not put that there though, -3 and then up 7, so -3 horizontally and 7 vertically. And we're very, very comfortable with that way of graphing because we've done it forever, really, it feels like, I'm sure. So just want to kind of again mention that this, it's going all over the place. This is typically an XY data point or a point, and this is our movement on the horizontal axis, and this is our movement on the vertical axis. And I'm not sure if you even know what this is called, but as it says here, our old coordinate system is actually called the Cartesian, C-A-R-T-E-S-I, that's an I-A-N, Cartesian coordinate system. And a lot of instructors will even say or use the word rectangular. And I think you're going to see today why we tend to use this as the rectangular coordinate system. Okay, so now that we kind of rehashed what we already know, let's look at our new coordinate system. Look at how circular it is. Isn't that very beautiful? It is going to be called, as the title of your notes suggests, the polar, I have to keep remembering to switch over, the polar coordinate, again, you can't tell that my eye, coordinate system. And the interesting thing about this is the point right here is not going to be an XY, a horizontal, vertical movement. It's actually going to be an R theta movement, which is awesome. It's totally different than what you're used to, but R, which is what you've heard R before, and it is in fact what we deem as the radius. And the theta is something we're very familiar with, which is the direction, angle. We've been using that in vectors a lot, so that works. It's very easy for us to understand. Now when we graph it, here's some tips to graphing. First rotate around, find your angle theta. So find angle theta. That's the first thing you want to do. Once you have your angle of rotation found, then you're going to move out steps towards or out, like outside of the circle, outside rings, if you want to think of it that way. So if R is positive, and that's really important to note, if it is positive versus negative, it does do something different if it's negative. If R is positive, move R steps toward angle, and I'm going to explain what that means in a moment. Actually, I'm going to demonstrate it toward angle. And you know what? Oops, that says angle right there. Okay, angle. And if R is negative, move the absolute value of R away from angle. And that's my angle symbol right there. Okay, so let me just kind of show you. showing helps a lot. Now before I show you, I'm going to start that I'm going to have to do some labeling, just like on an XY axis. You have to have some sort of scaling going on there. So this is going to be 0. If you look at this, we know that this is pi over 2. Notice we are using radians. This is pi, and this is, of course, 3 pi over 2. Now if you look at how we're breaking this up, we're breaking it, each quadrant into thirds. So this is going to be pi over 3, and this is going to be not pi over 3, geez. How about pi over 6? And this is pi over 3. Over here, we have 1, 2, 3, 4 pi over 6, which is actually 2 pi over 3. This here is 5 pi over 6. And let's go all the way around just to make it easier on ourselves here. When you are graphing, you will need polar coordinate paper. It is in your note guides, but if you need some extra, you can either print them easily enough by just doing a Google search of polar coordinate paper, or come on in and grab some hard copies from me. Okay, so we have our template here with our scales, and so I'm going to graph this point right here first. And like my tips over here state, you're going to first find the angle of rotation, which in this case is pi over 6, and then I'm starting at the center here, the center of the circles, and actually going to count 1, 2, 3 out from the center. So 1, 2, 3 out from the center towards this angle of pi over 6. So that's what the second part says. If r is positive, move r steps towards the angle. And so we're moving it towards the angle pi over 6. So just to kind of show you, and let's actually label this as point A. So point B, we'll do the same kind of thing. I'm going to first rotate around to find pi over 2. So I'm going to do this right here. And I'm going to go towards the angle because the radius is 4, it's positive. 1, 2, 3, 4. So it's going to end up right there. That's my B point. Now C, notice we have a negative on there, and that makes it a little more interesting. We're going to first find that rotation of pi over 6. I wonder if, can I change colors on this? Oh, I certainly can. Look at this. I don't know, let's go green. Okay, just because I don't want to get confused here. So pi over 6, I'm rotating to pi over 6. And then instead of going 3 units towards pi over 6, I'm going 3 units away. 1, 2, 3 from pi over 6. So notice that as long as you're on the pi over 6 rotation, any point is going to be somewhere along that line. I'm going to say that's point C over there. That's this one right here. And just because I figured out how to change colors, I'm going to go with the bright, nice pink for point D. Now 11 pi over 6, remember directional angles rotates from 0 counterclockwise, so we're going all the way around to 11 pi over 6, and we're going 1, 2, 3, 4, 5 units out. So that is, in a nutshell, how you graph on the polar coordinate plane. Now, again, you need to know the angle of rotation, which is your directional angle, and you need to know your radius. So if you come down here, oops, I'm going to try coming down there. Hold on a minute. I need to, right here it says, now graph E, the point -3. I went way too far up here. And I'm focusing on this one right here. Graph -3, 7 pi over 6. And what can you conclude? Well, if you rotate 7 pi over 6 all the way around, you're over here at this angle right here, but when you're starting at the center, you're not going towards 7 pi over 6, you're going to go away from it. And you know what? It ends up in the same exact spot as point A. So point A and point E are the same, so what can you conclude? Well, same as point A. Give 3 other ways to name that point. Well, we know one because we already have point A. And so my first point that I'm going to name is 3 pi over 6. Why not, right? And you know, you can do a couple different things here. You can take 7 pi over 6, I'm going to do that right over here, and add 2 pi onto it to rotate it all the way back around again. And of course, when you add 2 pi, let's put this over 1, get a common denominator, so I'm going to multiply top and bottom by 6. And what do we end up with there? We end up with 19 pi So my next point is going to be 19 pi over 6. And now keep in mind that my original point was -3. So if I'm going back to the location of 7 pi over 6, that rotation, I need to make sure I put -3 right here. And a third one, you could do that same exact thing, take pi over 6 and add 2 pi to it. And there's obviously an infinite number of answers here, but I'm going to just do that really quick. I'm going to use pi over 6. I'm going to add 2 pi to it, which is the same thing as 12 pi over 6, which gives me 13 pi over 6. So that rotation of 13 pi over 6 is the same as pi over 6. So I'm going to say 3 and 13 pi over 6 are 3 different points, or actually they're the same point, but 3 different ways of expressing them. Okay, so now I'm going to erase this so you don't get that confused with what I'm going to say next. And you are going to be working on your practice here. And note that it says page 539 in section 6.4, 7 through 12, 23 through 26. Really keep in mind that you're finding 3 more possible coordinates for each point given, and really just ignore in that 23 through 26, ignore the book directions. It will help you, that's directions, sorry, directions. So just ignore the book directions and follow these directions right here. Okay, thanks for tuning in.